Okay, yeah, thank you. This is the second part of my talk, and in the first part of my presentation, I basically talked about the vertical integration. So taking something like ShipConstructor and connecting it to a PDM or ERP or some data management system. In the second part of my presentation, I'm talking about what I consider horizontal integration or CAD conversion, if you want, because it's mainly about converting different or data from different CAD models that are used along the development process. So you might start in the early or initial design phase with one system, and then you might continue your design work in some basic or detailed design with a specific tool which is tailor-made for this type of job. And then even afterwards, if you go into something like work preparation or even manufacturing control, you might again use another type of tool such as Nestic. So we saw Marcel's presentation earlier to basically create production geometry or any planning for the belts or for the assembly. So basically, what is this all about? CAD conversion as such, if it's about mechanical CAD system, is something that has been resolved quite a long time ago. Especially this was the matter that was addressed using or by the STEP standard, and STEP basically nowadays is supported by most, if not all, of the mechanical CAD systems, and those systems can import-export STEP 3D models, few attributes attached to them, and that works more or less out of the box, no problem with that. If it comes to the shipbuilding specific CAD systems, such as SSI or Weaver or CADmatic or those we mentioned them earlier, they have a bit more information inside in their data model. I mentioned this and we call it design intent. So the design intent is a bit more than just 3D geometry, but it describes that certain elements like plates are connected to each other and are topologically bound to each other. Same could be true for piping parts. So the end of a pipe is basically topologically connected to a flange, and the flange again is topologically connected to a valve, and so on and so on. And you can describe these topological relationships, and typically those shipbuilding specific design systems are able to do this. But as soon as you do a step-based data exchange of CAD geometry or CAD data out of those systems, then you lose that topological information. It's just gone. So you can't get it, or it's very hard to get it back. Therefore, we basically have implemented as part of our OpenPDM Ship platform capabilities to take data out of the shipbuilding specific CAD systems, including all the topology, including all the parametric ships building specific features like profile end cuts or plate seam information, and whatever you can define in shipbuilding CAD, we can take out of there, and we can also create it in the destination system. Again, that basically enables us to turn designs from one CAD system into another one. So it can be from an early design into a basic design and a detailed design system, but it can also be between different CAD systems in the same stage of process. I think most of you have heard about that nowadays. It's not unusual that designs are sold. So one engineering firm or one shipyard has a design, has built that ship, and another shipyard want to build a similar ship, and they basically buy a design and adapt it. So that's often happening in the Navy industry. So there are several frigate designs being sold in the last few years, and then again the question comes up, how can I get this design from the system it was originally created into probably the system where the ship is supposed to be built then in the environment of the company, the shipyard of the Navy that bought that design. This is all addressed by what we offer here and what we have developed over the last few years. Just to mention it, the biggest conversion that we ever successfully did, was in Maya Group, and we basically developed a conversion between CATIA of Maya Werft in Papenburg. They've basically used CATIA to make a complete cruise ship design, And the sister ship of it was and is supposed to be built in the Toku shipyard, which is basically the same company. But in Toku, they are still using different CAD systems, namely Aveva and Cadmatic in this case. So we basically took that entire cruise ship design. It was 4.5 million parts, 3 million outfitting parts, 1.5 million steel parts. Took this entire design and turned it more or less automatically into those Toku shipyard CAD systems. And we had a success rate of that automation of more than 90%. There was less than 10% of the data needed, for whatever reason, needed manual interaction or post-processing afterwards. So that's basically just to give you an idea of what can be done. That's the biggest thing that we ever did, and even the biggest thing that I have ever heard of it. So we've seen this already, and basically what we are talking about now is the integration between those guys. Not this way, but this way. And especially the example I'm going to show is we are taking NAPA, or one of the NAPA tools, which is NAPA Steel, which is used for early steel design. And we are taking this data, all topology, and trying to put it into ShipConstructor. That's my example that I'm going to show. How can we do this? How do we know about this? We have done a lot of research in the last few years, and we basically investigated how those vendors, how those CAD systems store their data. So we know about those data structures, those data models that are in these ShipConstructors or Avevas or Siemens, NX or Cadmatic systems. We know how they work, we know how they are structured, we know what the information is in there, what the information quality is, what the information detail is in there, and we are able to map those one to the other. And if you are interested in reading a bit more and learning a bit more about this, in the ICAS conference 2017, 2 years ago, we did a paper which is basically trying to describe this a little bit, and we did it together with those companies that are mentioned here. So SSI was in the team at that time 2 years ago already, and we together basically created the input for the paper, which basically was take this assembly, as you see it here, and model it, same thing in all of those systems, and look into the data structure that was created in the databases of those systems, and compare it, and put it one next to the other, and see how does a plate look like, how does a pipe look like, how does a profile look like, how does a profile end cut look like, and so on and so on and so on. And given this information, then we were able to basically describe mappings between those different data models. And that's basically what we are implementing in those CAD conversion type of integrations that OpenPDM Ship is able to provide nowadays. Same picture as you have seen before, with the difference there is no team center anymore, but the information sink now is ShipConstructor, and the information source is NAPA, and it's not ShipConstructor anymore. So we are taking data out of NAPA. If it is completed, so it's still work in progress, but as soon as it is completed, there will be something like a NAPA connector that in fact exists already, but there will be the Shipbuilding write connector that we do not have really completed our development with. And the same is, as I explained it earlier, there's some trigger needed, somebody needs to trigger the exchange and need to define what's going to be exchanged, and then this engine starts to run, takes data out of the source, does the mapping, processes the information, and basically delivers it at the end in the data sink, in the receiving system, and then something happens probably in the user interface or elsewhere of the receiving end. Yes?
Are you saying that you actually have a NAPA Steel and ShipConstructor converter?
No, it's still work in progress, so we do not have it, but we intend to have it early next year, something like this.
Are you making it, or is NAPA making it?
Okay. This thing is in place. It exists. It's a product. We have done it together with NAPA. So everything we do with those connectors, we don't do on our own, but we are doing in close collaboration with the vendor. That's why we need to be vendor neutral, because we need to talk to all those vendors. If we would be a reseller of one of their systems, the others wouldn't talk with us anymore, probably. So this thing is in place, it exists. We have a fully developed integration of NAPA Steel into Aveva Hull that's in productive use by shipyards. And we are intending to do the same for NAPA Steel to ShipConstructor. And it's work in progress. I'm showing the status in one of my slides at the end.
Yeah, because it was no more than a year ago, NAPA was still not able to deliver a solid model.
What model?
A year ago, I requested NAPA
To deliver?
was not able to deliver a solid model.
Yeah, the NAPA thing, so we finished the development. That was 1.5 years ago, we started that development with NAPA, and the development was finished. So Maya Toku shipyard is using it for production since 6 months. HHI in Korea is heavily testing it and should have started using it in production by now. Several other shipyards are testing it. So there were 5 shipyards in total who were basically part of that development and who put their requirements into that development. So we covered the requirements of 5 shipyards. That doesn't mean what's there already works for each and every shipyard, because those 5 shipyards did not have the same requirements, because they have different ways to use NAPA, and they use NAPA for a different period of time in the development process. Some stop earlier and make the step to the next CAD system. Some use NAPA very, very long. So it's all different. But I think my gut feeling would say we are covering about at least 80% of the possible requirements in that existing NAPA export. The ShipConstructor import is work in progress. I'm explaining where we are today, and we will see a little AVI as we saw for the Team Center integration as well. And here it comes. And I think it needs some help from your side again. So here we see NAPA Steel. As soon as the video starts, just click on that picture, so then it should start. Got stuck. Not working?
It's animating here.
Oh, that's a pity. It's wrong. So I did it in both presentations. I did it at the same time. I didn't care about telling PowerPoint where to show the video. So maybe it's another computer or whatever. Okay, so whoever is interested, I'm here until tomorrow noontime. I will give you a private movie show on my computer. What we are supposed to see here is NAPA Steel is opened. That's the NAPA Steel demo ship project. It's loaded. We are selecting, I think it's kind of a tank bulkhead from that model just for demonstration purposes. And this is then basically exported from NAPA. It's at that point in time, it's still file-based, manual file export, and then import into ShipConstructor. So there's no OpenPDM automation yet in place, which is just a matter of doing it. But the important thing, of course, is get the data out of and into the CAD systems, and then building an automation around it using OpenPDM is not really rocket science for us. So taking the data out of NAPA, putting it into a file, and basically opening this file in a piece of converter that runs still today in a black command line window, so it doesn't really even look nice, but it basically does the necessary data mapping and conversion, and then at the end delivers it into ShipConstructor through the Genesis interface. So, and basically that results in plates and profiles at that point in time being created within ShipConstructor database, and then we open it in ShipConstructor, and then we see it. So I can show it on my computer afterwards. Sorry for that. And now this stops working as well. I think there are not many slides left. If you can just click and advance the slide from your side there. No, that's not it. Nice picture. Aha, we are starting over again. Okay, no problem. Let's do this again. Okay, so current capabilities and status of the development. NAPA Steel connector, everything that's in NAPA Steel can be exported. Every plates, panels, seams, stiffness, brackets, cutouts, whatever elements are there, you get out of them, out of NAPA, including, I mentioned it, topology. Those guys here, if they have parametric description, they will be parametric in the export. All the attributes that are in NAPA Steel, or structure, which is a bit simple in NAPA Steel. So we have block, panel, part, but anyway, the structure comes as well. Status is, this thing is there. So I mentioned it already. There are shipyards using it for productive purpose, not in the ShipConstructor context, but in the context of other CAD systems. ShipConstructor connector. We create native plates, brackets, profiles in ShipConstructor. We create attributes attached to those parts. And I also mentioned already, it is still work in progress. So far, we have only steel import supported by the Genesis API. So as soon as there is import capability in the Genesis API for other discipline objects like piping and so on, sooner or later it will be there. Then we will be able to use it as well. Doesn't make sense for NAPA Steel, of course. We would like to create topology of steel parts. It's not yet available in the Genesis API, so that's basically the most important thing we are looking for. Also, this assembly structure, panel block thing, we are still missing in the Genesis API, is also, I guess, supposed to come soon. Yeah, as I said, creation of non-steel objects is something that is probably also an issue sometime next year, but doesn't make sense for NAPA Steel because it only is about steel. This is it.